Hello and greetings to everyone. My name is Jatin Asnani, currently pursuing my Masters in Construction Engineering Management from CEPT University. As a part of a Studio 2, which is Construction Project Execution, Monitoring and Control, we have chosen a project mixed use project. So coming to the project details, the project it is situated near Ahmedabad, in which plot area is 15,119 square meters, and total built up area of the project was 1,03,005 square meter. Overall cost of the project was rupees 210 crores, and the core and shell cost was rupees 100 crores, and it was given to a private contractor from Ahmedabad. Uh, Project was started on September 2021 and it is expected to be completed on December 2024. On the right hand side we can see the current status of the project, in which there are total 5 towers, in which tower A, B and C are minus 2. They have 2 basements plus ground floor and 21 floors, and the block D and E have 2 basements, ground and 20 floors. And the contract type was square feet base, in which labor and material cost were included. Current status of project suggests that the block A is at the level of G plus 3, block B is at the level of G plus 5, block C is at the level of G plus 4, block D is at the level of G plus 8, and block E is G plus 7. To the pour planning. In floor planning, the slab cycle for our project was 17 days, in which only one pour was focused. The activities included in the slab cycle were line centering, reinforcement and shuttering work, leveling and checking of slabs, electrical conduits placing, and finally the concreting. Here we can see that the formwork used at site were conventional and speedy formwork for shear wall of lift. For the column formwork, we can see the image, in which the various components we can show, like waller, anchor nuts, tie rod, plywood frame and bracing. And on the bottom side we can see the formwork for slab and beam, in which forehead, U-head jack, couplers, couplog ledger and vertical and base jack were provided. For the pour planning, the scope of work was included in the project was block A, in which the pores were divided into two parts, pour 1 and pour 2 of different areas, and the components for formwork like vertical ledgers, base plate, forehead, etc. were calculated on the basis of thumb rule, which was followed at the site. The thumb rule was generally prepared after consulting the site personnel. In the formwork planning, we have calculated formwork calculations by thumb rule, formwork set code repetition, labor requirement and productivity, and finally the formwork checklist. Formwork used at site for slab beam and columns can be shown with different components and materials which were used for it, and the set code repetition was also carried out in block A, in which were plot 4-1 and 4-2, in which the total repetitions they were carrying out was 10 for each pores. Next is the thumb rule calculations, and here we can see in the table that the thumb rule considered for number of verticals or A into area into 4, the total area, which was 584.7 square meters. Next is the base plate required, forehead required, ledgers required. Same for all the components, we have considered the thumb rule, and we have calculated the total number of components required for each block. The total quantity of number of articles required after calculating it was 3280 numbers, in which we have taken the pore area and the thumb rule considered, which was assumed at the site, and it was considered at site. After that, we have calculated the productivity for various blocks, in which the highest productivity was for block B and C, in which total 24 numbers of labor were deployed. Here in the table we can see that the total 5 blocks are there, and the total 2 pores are there for each block, and the areas for each pore, number of labors, and for finally we calculated from the number of labors and area, we finally calculated the productivity in square meter per day and square meter per man hour. And here we can see that the productivity is highest for the block B and C, followed by block A and DE. Next is the linear responsibility chart. In the linear responsibility chart, we carried out the quality organization structure. After that structure, we found out the roles and responsibilities of each and every personnel involved in the quality control. After that, preparation for linear responsibility chart was done and carried out. Here is the sample table which shows the linear responsibility chart. In the left hand side we can see the legends which shows the actual responsibility, general supervision, must be consulted, may be consulted and must be notified. And the various person involved were client, contractor, architectural designer, structural designer, third party material testing agencies, etc. And for that we have calculated almost 28 quality activities, and for this portfolio I have shown the sample of 5 activities, and the detailed activities are shown in the report. Here we can see that for the defined quality objectives, client is actually responsible for preparing it, and the senior engineer from the client side is consulted for preparing the quality objectives. Next, coming to the define material quality requirement, the client is actually responsible and he consults the senior engineer. After that, the contractor is generally supervised for the quality material selection, and project manager is notified for the material selection of vendors for core and shell material is generally done by the contractor, in which project manager is the actual responsible person, and the QA/QC manager is notified for the vendors who are selected, and QA/QC manager supervises the whole process. After that, the client is consulted for the selection of the vendors for the materials which are required for the core and shell. Then the below pie chart shows the different responsibilities of different stakeholders, in which the highest responsibility is of contractor, which is 54%, followed by the client and the third party testing agency. Plus and delta for the linear responsibility chart were that the architect's involvement in material selection helps in exploring more and more material and quality material. The MEPF and structural designer were under same roof, so the conflict resolution is quick and it is solved easily. The client also supervises the construction is as per drawings or not, and he also checks the slab reinforcement placements frequently. The delta for the linear responsibility chart were that the testing of materials is done by the third party agency, which is delta, so it should be done at site. Proper QA/QC plan is also not there at the site, so it should be prepared and maintained at the site for better quality product. The quality client's engineering team should be involved in on-site tests rather than just being notified. Next, coming on to the quality laboratory, we have the hierarchy for quality lab personnel in and the existing QC layout. We have also proposed the QC lab after consulting the site personnel, and we have also conducted various site visits for this assignment. So hierarchy of quality lab personnel includes the QA/QC manager, which sits in the head office, and for the site we have a project manager, QA/QC assistant manager, and QA/QC engineer at site. Here we can see some images of curing tank. We have three curing tank, one for the 7-day cube testing and two for the 28 days cube testing. The site also have a CTM machine at the site. In the existing, we have also prepared the existing QC layout in the AutoCAD, in which the site has only the curing tank and the small QA/QC laboratory, in which only CTM machine is there and Q molds are there. After doing the assignment, we come to the conclusion and we prepared a QC layout which is proposed, in which we provided the file rack, storage area for different equipments at site. We have also raised the platform at some height to keep the weighing balance and all equipments at the platform, and we also provide a opening for a proper ventilation. Next, the list of equipments available at site were CTM machine, weighing balance, concrete mold, and slum cone. We have provided the detailed list of equipments, including the how many numbers were there and the capacity of each and every equipment at the site. And on the right hand side, we can see the list of equipments required on the site as per CPWD. We have suggested 15 equipments at the site and have highlighted the 7 main equipments which should must be provided at the site. Next topic is cost of quality. In cost of quality, generally there are two types of cost of conformance and cost of non-conformance, which is also called the deviation cost, and cost of conformance is called quality management cost. In quality management cost, we have prevention and appraisal cost, and in the deviation cost, we have the internal failure cost and the external failure cost. For the procedure for the NC non-conformance reported site is the first of all the NC is raised by the client's team, then the non-conforming NCR is submitted to the assistant QA/QC manager. After that, the submission of the method statement of client engineering team is provided, and the measure statement is also provided by the client. After all the countermeasures and the methods for doing it properly, then it is reviewed by the client engineering team, and finally the NCR is closed if the client is satisfied. For the quality management cost, we have considered the cost of prevention and appraisal, with the total of it was 29 lakhs 40,000, in which the cost of prevention was 2 lakh 33,749 rupees and cost of appraisal was 27 lakhs 6,000, in which the prevention cost includes the preparation of QA/QC requirements and checklists, establishing the QC laboratory, and the cost of equipment is in the prevention cost, and the total was 2,33,000. And in the appraisal cost, we have considered the staff salary and labor wages. Staff salary mainly includes the people who are personally who are included in the QA/QC process, and the cost of equipment calibration and cost of external testing were included in the appraisal cost, and the distribution of both the cost is shown in the graphs. After that, we have observed the two NCs at the site, in one which was the honeycombing observed at the slab of fifth floor of block A, and we can see the images and the non-conformers which the slab in which the reinforcement can be clearly seen in the slab. So the possible causes were lack of curb blocks, poor workmanship, concrete having low workability, and the poor inspection done during casting. For that, we have also calculated the cost of repairing it, in which we have considered material cost, labor cost, and inspection cost respectively. The total cost came out to be 1 lakh 40. Total cost came out to be 1,440 rupees. And the second NC which we observed was also honeycombing in the beam of 7th floor of block E. Coming on to the next topic, which is project risk management. For the project risk management, the scope of work was analyzing the risk to the project for total two floors of tower A, which is 5th floor and 6th floor. For this, the procedure of risk analysis includes the importing the XCR file which we have prepared for the project, in which we have done the primavera planning also. Then after that, we prepared the risk register and imported it to the imported into the primavera risk analysis. After that, we have carried out the pre-mitigation risk matrix, and the post mitigation risk matrix was generated in the primavera risk analyzer. There were total 32 risks identified for the project, in which 13 number risk was labor shortage, which come out to be the very high category. After doing the mitigating measures, the risk category was came out after doing the mitigation, the risk came out to be the medium category. After calculating the risk, we have also generated the different graphs in which distribution graph was prepared for finish date and duration, and tornado graph was also generated for the duration sensitivity of the project. In the first graph, which is the distribution graph for finish date, the yellow arrow it indicates the deterministic time for the achieving the project date is 13%, and the project can be completed on 28th April 2024. The project can also be completed at the 27th May 2024 after calculating all the risk and all the delays for incurred in the project. And for the duration, the yellow arrow indicates the deterministic probability of completing the project is 380 days is 13%, and the project can be completed earliest in 373 days, and it can be delayed due to all contingencies and risk in 402 days. At last, we can see the comparison of planning techniques in which CPM and PERT were considered, and the difference between both, we can see that the deterministic probability was 388% for duration, and for the finish date it was also 13%, and the finish date came out to be 12th May 2024. Finally, after concluding the slides, the key learnings for the project were: the planning and scheduling are identified on the on-site slab cycles and key dates, the type of shuttering used on labor sites, and repetition set code repetition along with its productivity. The labor productivity was calculated, and the difference between the actual and the calculated productivity was analyzed for poor planning. For Primavera risk analysis, it allows the project manager to perform quantitative risk and qualitative risk for the project. It also identifies the potential risk, estimated their likelihood and impact on the project outcomes, and develop contingency plans to mitigate them. As we have seen in the Primavera risk analysis, 32 risks were identified, and deterministic probability was also given for the duration and the finishing date of the project. For the LRC, it gives the idea of various stakeholders involved and the roles and responsibility of them. Multiple stakeholders were involved in the single activity of QC management, hence it also depicts the interdependency between all the stakeholders. The QC laboratory was examined on the site by conducting the regular site visit. The roles and responsibility of third party quality agencies and their role in quality management, documentation of different tests at the site, and list of tests which are followed at the site. The persons involved were also identified, and their roles and responsibility, as I have stated earlier. The cost of quality helped in identifying each and every cost associated with the quality, and we also came to know about the NCs at the site which were there. The process and cost of incurred due to same was also identified. There were total two NCs at the site currently till now, and the cost for it was 3,500. Thank you.